for Hapagee. My host did give you instructions as to, we have disabled chat, and if you want to speak, then you will raise your hand. Remember yesterday what I told you about respecting each other? So we are here to learn, and I do want to create an environment in which we will learn and be respectful to each other. So at the end of this lesson, I want you to learn more about changes of state, which is evaporation, condensation, freezing, and melting. Then we'll go on to density, and I will explain what density is when it involves mass and volume. And I'd also like to talk to you about density and the different materials that we have in density. Okay, so I'm going to proceed with a recap from yesterday's lesson. So yesterday we spoke about the particle model that describes particles in a solid. So the arrangement was that they were very closely and regularly packed, and they were locked into a position. That means it is in a fixed position. And the only movement that was allowed was that they vibrate next to each other. And they vibrate next to each other because they are very, very close next to each other. So it causes a vibration by them pushing against each other. And they are held together by strong forces. There's also spaces between them, and the spaces between them are very small. And there's absolutely nothing between the spaces, no air, absolutely nothing. And then the particle model describes the particles in liquid as follows. They are close together in a locked position. Can you just give me 1 sec? So this the particles are, I did the solid, the particles in a liquid. So they are close together but not locked in a position. They are in a constant motion and slide past each other. They are held together by moderately strong forces, and the spaces between them are very, very small. So that means that they are larger than the spaces between in a liquid, but not so much in a solid. So we could say that they are in a constant motion, that they're sliding past each other. So remember how I showed you yesterday about washing your hands? And if you move your hands over each other, that means that they are sliding each other. Now the particle model in gases, they move in a fast motion, and that's because they are not arranged in a specific way. They are free to move. The spaces between them are large, and this makes the forces between them very weak. Right. Since the particles of the liquids and the gases are in constant motion, they are able to diffuse. Now, this means that because they're in constant motion, they are able to spread out. So diffusion is a process in which particles spread out through random movement from high concentration, where that means that there's a lot of the particles, and it moves to areas of low concentration until it is evenly distributed. So now I'm going to move on to when two substances mix, the particles intermingle until their composition is uniform throughout. So this is called diffusion. And the process is much faster in gases than in liquids, as I explained yesterday, because the gases particles are further apart. Now we're moving on to why this happens, why solids, liquids, and gases change their states. Now you have a better idea of the particle models of matter and their different states, which is the solid and the liquid and the gases. And you are now ready to know about how they behave when they change its states. That means how a liquid moves to a gas and a liquid moves to a solid, and also the two new words that I'm going to ask you about that told you about yesterday, when a gas goes directly to a solid and a solid goes directly to a gas. I will ask you about that a little later on. In science, a change of state basically refers to a change in physical state. That means that the physical change that has state has changed and the liquid changed to a solid. Now you'll ask yourself, what is this process called? So the process is called, it can either be through heating and cooling. And heating and cooling are the two main processes that changes the state of materials, of matter. Now I'm going to explain. Now we have evaporation and boiling here, and then we have melting on your right hand side. Now these two processes are heating, and now we have condensation in the middle and freezing and solidifying. Now these are cooling phases. Now what happens is when liquids change to a gas, the particles move much further apart from each other. When the liquid changes from a liquid to a gas stage. So this means that the particles, when it was in a liquid, as it is either evaporating or it is boiling, then the particles tend to move further apart. It tends to diffuse further away. So that's how it changes to a gas stage. Now, if you, after this lesson, you can go to your kettle and put it on, or on your stove, you can boil water, and you'll see that the particles in the water are concentrated because the water is contained in a container. And as it boils, then the gas escapes and the gas diffuses to the particles move around further. Now I'm going to explain condensation when gases changes to a liquid. Now the particles lose heat. And as they lose heat, this means that they lose energy. And because they lose energy, they actually slow down and they move closer to gas molecules. Right. Finally, they collect together to form a liquid. Now, if you can relate this to the water cycle, so when you learned in earlier grades that when the water vapor rises from the ocean and it goes up, the water vapor goes up to form clouds. And as they cool, they join together and uh, the molecules grow closer together. And now because the molecules are going closer together, they can collect and it becomes, they condense to form liquid. Then I'm going to move on to freezing or solidifying. So we have liquid changes to a solid. Now the particles of a liquid slow down enough that their attractions can arrange themselves into a fixed position as a solid. So basically what this means is that when we have the particles in a liquid, they slow down and they attract each other. And because they're attracting each other, that means they solidifying, they becoming a solid. So remember, if you can think back and you can visualize the arrangements of particles in a solid, they are in a fixed position. It has a definite phase and it can position and it cannot move. So it becomes a solid. Yes, John. I'm going to ask my host to unmute you.
Um,
I can hear you. Hi.
You're breaking up.
I'm breaking.
You're breaking up.
There seems to be some technical difficulty with regards to this lesson. So I will go a little slower and I'll ask my host to work on the technical difficulty because we also have the camera and it's not functional at the moment. So bear with me, and this lesson will also be online. So you can see, as long as you can hear me, it's fine. But you can be able to access all this material later on, and it will help you when you download it from YouTube, and it will help you learn the lesson. Okay.
Okay,
So
thank you.
you're welcome. So solid changes to a liquid. Okay, the movement of the particles increases, which enables them to move past each other and form a liquid. So this means that the particles increase, which enables them to move in a faster way, and they become a liquid because now they are move around each other. So we have change of states which involves energy. Now, for matter to change from one state to another, it participates, the particles must gain or lose energy. So this means that when particles are changing from one form to another, like from a solid to a liquid to a gas, it either gains energy or it either loses energy. And the following diagram shows that the change of state of a substance, it must either be heated or cooled. So another way for it to change its state is it would be heated or it would be cooled. And as I explained earlier, but the diagram shows you in a nicer way. So in a solid, if you add energy, it becomes a liquid. And if you add more energy, it would become a gas. Yes, Nati. I'll ask my host to unmute you.
So,
Can you hear
can
me?
I? Yeah, I can. Before I speak, I'm using my big brother's computer. Before I speak, and also, isn't it you see that like the it changes from solid to a liquid and liquid to a gas, isn't it?
Yes, it's changing when we add
But
energy. So when you're adding energy, it's changing to a liquid, and when you're adding more energy, it's changing to a gas. And now
but
also,
al-
okay,
but also they say that there's a fourth state of matter,
yes, but now for this
plasma.
class, which is
Plasma.
okay, well, for now, for grade 8, I only want you, and for this lesson, I'd like you to learn the solid, the liquid, and the gas, and then you can go on to that as you go on to higher grades. Okay,
Yes. Thank
okay,
you.
no problem. So if you want to remove energy, then you're going to change from a gas. If you remove energy from a gas, it becomes a liquid. And when you remove more energy from a gas, it becomes a solid. So I want you to remember this. In a solid, when you add energy, it becomes a liquid. And when you add more energy to the liquid, it becomes a gas. And now in a gas, if you remove energy, it would become a liquid. And if you remove more energy, it would become a solid. Okay, so now when I say adding energy and removing energy, I'm talking about adding energy to the particles or removing energy to the particles either by heating or cooling. Now, this was not supposed to happen. Okay, so basically, melting and evaporation are processes that require heating, and condensation and freezing are processes that require cooling. So I want you to remember, melting and evaporation are processes that require heating, and condensation and freezing are processes that require cooling. So this part that I'm circling around is very important for you to remember. Now, also a nice learning technique when you're going to learn is that you can learn through mind maps. So you can copy the diagrams down, you can add it, then you can add this part about melting and freezing to the diagram, and then condensation and freezing, what happens to it. And it will make your learning more interactive so you can learn holistically and gain the information that you need to gain. So we have melting and evaporation. So when a solid is heated to reach its melting point, it will change to a liquid. And this is a process that we are familiar with because we can see how ice melts. So all of you in your life, you would have basically seen how an ice tube melts. And this is basically how the change, one way of changing the state. But you want to know, is melting the same as evaporation? Does anybody know that answer? Would anybody like to answer? Yes, John. Hi. I'll ask my host to unmute you.
The answer is no,
Why?
because evaporation means it forms from a liquid to a gas.
Okay, and melting?
Melting is from solid to liquid.
Very good. Well done. I'm very happy with that answer. So now, for a solid to change into a liquid state, the particles in the solid need to be freed from their fixed position in a solid state. So now you're going to ask yourself, how does this occur? We want to know how the solid changes into a liquid state and how the particles in a solid need to be freed from their positions in the solid state. So imagine that you are holding your hands with a group of learners and everyone is jumping in the same place. So you all remember the picture that I showed you yesterday? There was a crowd of people and they were all next to each other. So now you're holding hands and you are all jumping together in the same place, much like how solid particles vibrate in their fixed position. Okay, so you can picture the people close next to each other and they're jumping next to each other. So this is basically how particles in a solid, they vibrate in a fixed position. And the more energetically and randomly everybody jumps, then the more difficult it would be for them to keep holding their hands. So now if you're all jumping together and if you jumping up, because you're jumping now, your movement becomes a bit more random. So it's difficult to keep holding your hands. Obviously, your hands are going to free each from each other. Now, relate that when a substance is heated, the particles are given more energy. And by giving the vibrating particles in a solid more energy, their vibrations will become more and more vigorous. So now when you are applying energy and you are to a solid, the vibrations become vigorous until the solid particles are able to shake themselves loose from their fixed position. And this is when you apply heat. So now these solid particles, they are shaking themselves loose from their fixed position. And now the forces between the particles are no longer able to hold together tightly, just like how your hands broke from each other when you were jumping in a random energetically way because you couldn't keep it together. Now the heat separates the particles from the solid, and the solid melts in that way. Okay, so now we will ask what will happen if we add more energy to the particles in a liquid state? Yes, Andy. I'll ask my host to unmute you.
Hello, ma'am.
Hi.
If you add more energy to a liquid state, it will change to a gas because then the particles will have more energy to move freely around.
Yes, and then eventually it will become sorry, if you add energy to a liquid state, it will change to a gas. Yes, that's correct. Now we were
Yes.
talking about adding energy to a solid to become a liquid.
Yes.
Okay, very good.
All right.
Very okay. Anyone else that wants to speak? Andy, should I speak to you? Hi, may I
Ma'am,
ask my hi?
but also like, isn't it like, for example, water? If we add more energy to the water, it would turn into a gas. But it's still water. It's just that the state has changed.
That's only when you heat the water.
Yeah.
That's when it will change to a gas. So when you apply heat to it. Is that okay?
Yes, ma'am.
Okay, no problem. So I'm going to move on to why, Nati, do you want to say something?
It's everything's good. Everything's good.
Okay, good. So we're going to ask ourselves, what will happen if we add more energy to the particles in a liquid state? So the particles which are in a liquid state will whiz much faster than they are when they are heated. I'm going to go through this lesson and then I will take questions. Okay, So soon some of the particles near the surface will have enough energy to escape out of the liquid. So now, as the previous learner said, that if you have water and if you heat the water, then the energy would cause some of the molecules and the particles to escape. And once they are free from the force, they hold them together in a liquid state and enter the gas state. So now the molecules separate from each other and then they leave the liquid state and then they enter to the gas state. So the gaseous state is sometimes called the vapor state, which forms when we say liquid evaporates. So when we say liquid evaporates into water vapor, it is in a vapor state. And that process is evaporation. So now, why is this gaseous state of water is sometimes called water vapor? Now, the high temperatures of the liquid means that the faster it will evaporate. And the muddle of water we evaporate, let's say a puddle of water. Now, will this evaporate much faster when the pavement is hot than it would be on your kitchen floor? Now, you must know that your kitchen floor is cool, and then the puddle of water on the pavement is much hotter. So then the water would evaporate much faster on a hot, the puddle of water will evaporate much faster on a hot pavement because there's heat there as compared to your cool kitchen floor. Now, before I go to you, Zama, I'm going to ask, why do you think that why do you think when we hang washing clothes outside in the sun that it dries faster? Zama, can we unmute you? My host, can you unmute? Hi. Hello.
Hello.
Hi.
Hello.
I can't hear you.
Oh, we hang them outside so the water inside the clothes can evaporate.
That's very good. So when it evaporates, it turns into a gas, which it turns into water vapor. So due to time constraints, I'm going to move on. Is there anybody that does not understand? Then you can raise your hand. Okay, so I'm going to move on. Now, I want to ask you, is there a difference between evaporation and boiling? Yes, Takozo. Can I, Takozo? Hi.
Yes, ma'am.
I can't hear you.
Ma'am?
Hi.
Hello, ma'am.
Hello.
Can you hear me, ma'am?
Yes, I can hear you. Can you hear me?
Yes.
Okay.
Ma'am, my question was, how does the water evaporate from the clothes?
Okay, so the sun is basically heating the clothes, and because of that heat from the sun, it evaporates from the clothes. Is that okay?
Yes, ma'am.
Anything that you apply, any heat that you apply to water, it will evaporate the clothes. Now, evaporation takes place at all times. So while boiling occurs at a specific temperature, we call this the boiling point. Anyone else that wants to speak? May I ask my host to unmute you? Hi.
Hello, ma'am.
Hello.
I think there is a difference between boiling and evaporating because when you boil the water, you're only heating it and you're not really evaporating the air. But when you evaporate, the particles in the water are heated more than boiling, and it will start evaporating.
That is very, very good. So if we see here, evaporation takes place at all temperatures. That's very good answer. And now boiling takes place at a specific temperature. So remember, water boils at 100 degrees Celsius. Well done to you. Okay, so now when a liquid is heated to a boiling point, bubbles form in the liquid and it rises to the surface. And when this happens, we say that liquid is boiling. Okay. Evaporation occurs only at the surface of the liquid. So while boiling occurs throughout the entire liquid. So now evaporation, like when you hang your clothes outside, it occurs only at um, the surface. It starts with the surface, and as your clothes, the surface evaporates, it goes deeply. But with boiling, it occurs throughout the entire liquid, like in your kettle in your kettle, in the water in your kettle. Now, can you remember learning about boiling points in grade 7? The boiling point of water at sea level. I want you to do that as homework, and I want you to find out what is the boiling point of water at sea level. Okay, so we have condensation and solidifying. Yes, who would like to chat? Can I ask my host to unmute? I'm only going to unmute one person. Hi.
Um, Hi, it's me, John.
Hi, John.
Um, I just want to ask, can I say the answer to your previous question?
Yes, you can.
At sea level, the water boils at 100 degrees Celsius.
That's very good. So you were paying attention when I said that earlier on. That's very, very good. I am proud of you. Well done. So now, condensation and solidifying. When a gas changes to a liquid, the state changes. The state change is called condensation. So you must remember that. Condensation is when a gas changes to a liquid. Condensation is the opposite of evaporation. So evaporation would be the opposite when a liquid changes to a gas. Now, have you ever noticed that the little droplets of water that form from on the outside of a cold glass of water? So when you put ice water into a glass, you normally notice that little droplets of water form on the outside. Now, this is a form of condensation. It, um, okay, so when the temperature of a gas is lowered, it takes energy away from the gas particles. The movement of gas particles slow down to their energy as the energy decreases, and they will start to experience attractive forces. So basically, the energy uses attractive forces to either to decrease the gas particles, and these forces causes them to move closer to each other, and they will eventually return to a liquid state. So the gas particles, the energy decreases, they attract to each other, and it becomes a liquid state. Um, okay, so now what do groups of people, animals, or birds do when they get cold? They basically huddle together. And this is the same way that the gas particles are cooled. Or now, like if you see here, each bird is right next to each other. So then the gas particles, they combine together, they huddle together, and they condense. And this is how they become water droplets. Is there any questions? Somebody wants to ask me if anything for clarity? Can I ask my host to unmute one person? Hi.
Hello, ma'am.
Hi.
Ma'am, I just want to ask you a question about in a question which was a little bit before in this lesson. I just want to
Okay,
know
no problem.
when you sublimate matter which is turning from a solid to a gas, do you remove
Yes,
the energy or add energy?
that's a good question. So sublimating is when you're turning
Solid into a gas.
a solid into a gas. So a solid, you are actually um, I mean, you actually what the previous slide that I had earlier on, I'll show it to you, is when you are cooling, you are removing energy, and when you are adding, you are when you are heating, you are adding energy. Does that answer your question for you? So
So
when
which
you
means from a solid to a gas, you actually add energy.
yes,
Okay,
because
thank you,
it's
ma'am.
going direct. You're welcome.
Thank you very
Okay.
much.
You're welcome. So what would happen if we cool the liquid even more? Okay, by cooling the liquid, we would be removing energy from it. And as the liquid particles lose their energy, their movement slows down even more. And as the movements become slower and slower, the attractive forces become stronger. So I'm going to repeat that, because as the liquid particles lose energy, their movements slow down even more. And as their movements become slower and slower, the attractive forces become stronger. And the particles will eventually lock into position in the solid state. And they can no longer move freely. So when they locked in a position in a solid state, they do not move freely. And they are able to vibrate in their fixed position. So this is we saying that the liquid solidifies. It has become in a solid state. Okay, any questions about changes of state? Can I ask my host to unmute one person? Hi.
Hi, ma'am. Can you hear me, ma'am?
Yes, I can.
Ma'am, I'm going back to the boiling of the heat and the melting of the ices. And ma'am, can I ask about is it in my curiosity knowledge, is it possible that can the right ma'am the boiling point is 100? Is it possible? Can it go over 100?
Can I come back to you with that question? I know boiling point is at 100 degrees Celsius. But I will come back to you with regards to that question. Is that okay?
Yes, ma'am. Thank you, ma'am.
No problem. So we have density. So density, have you ever used the word density? Now, what do you think density would be? Perhaps you've heard it when people say, oh, this cake is so dense. What do you think that this means? Yes, Caitlin? Hi.
Oh,
Hi.
ma'am. Oh, yes, ma'am. I wanted to ask you about solidifying, ma'am.
Okay.
I didn't really understand it.
Okay. So I'm going to go back to it.
Thank you, ma'am.
So the particles eventually lock into position. And let me go a bit more. Okay, so when we say as the liquids lose their energy, their movement slows down. So now because they're losing energy and their movement slows down, we say that these movements become slower and slower, and then the particles start attracting each other. So the attractive forces become stronger, and the particles eventually lock into position in a solid state. Now, this is how solidification takes place, because the movement of the energy becomes slower, and then the attractive forces become stronger, and then they lock themselves in a solid state. Is that able to help you?
Yes,
Because
ma'am.
okay, no problem.
Thank you, ma'am.
You're welcome. Any other questions?
Ma'am, with evaporation and boiling points, when
Okay.
if liquid is in a kettle and you turn the kettle on, there's steam at the top, but it's only the top part that's evaporating. Why is it only that, not all of it?
When you say now why all the water hasn't evaporated, it's because
Yeah,
now, is that your question?
yeah.
Okay, so all the water hasn't evaporated because once it reached 100 degrees Celsius, the water has boiled, and then you stopped adding the heat. That means only so much of water has escaped from it. Now, the amount of water that you put was basically maybe 1 liter or maybe 2 liters. And then only certain amount of water or particles were free and escaped, not all of it, because you only added certain amount of heat to it. Do you understand? So the heat that you apply could only evaporate a certain amount of gas. Does that make it clear? Okay.
Yeah.
Okay. Any other questions? Yes. Hi.
Ma'am, I'm going back to your question about density. I was just saying, like, in this form of particles, the density is like adding the particles for it to change the speed of form.
Okay, I didn't hear you very clearly. So can I just explain this and then you tell me if it's what you said? Okay.
Okay. Yes, ma'am.
Okay. Density means how compact the mass in a substance of an object is. Is that what you said?
Like in particles.
Okay. So density means basically how compact the mass of a substance is in a substance. So like if you look at the box over here, we have the particles in the first cube. Now the particles are spaced out. And then the particles in the second cube, the particles are closer together. So this makes the density of the particles closer together because it makes, like for example, cake more dense because the particles are close together, like a chocolate mud cake. And a chocolate mud cake, because you have a lot of particles and it's very, very close together, then it makes it more dense as opposed to a vanilla sponge cake. Now there's less ingredients in it and it's not so dense because you're not putting a lot of thick ingredients in it. So it makes it less dense. Okay, so the scientific definition of density is basically mass is equal to, density is equal to mass over volume. So density relates to basically how much of mass is in a specific volume. Okay, and this tells us how much of mass, which is matter, exists in volume. So I see that we basically have 5 minutes left for the lesson. So I'm just going to introduce to you what density is, and then I'm going to continue with density and I'll do maybe 1 or 2 more slides, and then I'm going to continue with that for tomorrow. Okay, so what is density? You're going to say density is how much matter or mass is packed into a given volume. So basically, how much of mass is packed in a volume. So can you see that we have this large rectangular prism here? So we see there's a lot of mass in one volume. And then we have in a small cube, how much of mass is in that volume. So the equation for, but it can, the density of each can be different even though that the equation for density is basically D is equal to M over V. So D is equal to M over V. That means that density is equal to mass over volume. Okay, so just I'm going to do this slide and then we're going to stop. Okay, this section introduces us to physical quantities about, yes, does anyone have a question? I'll ask my host to unmute you before I continue. Hi.
Hi.
I can hear you.
Ma'am, I would like to go back. You said that condensation and solidifying are two different things, right?
Yes.
Yes,
You want
so
to know?
Yes.
Okay, solidifying is when when a liquid becomes a solid. Okay, and condensation is solidifying is when a liquid becomes a solid. Okay.
Yes.
And
Yes.
then when we have condensation is when a gas becomes a liquid. Do you understand?
Yes, yes,
Okay,
ma'am.
so
Thank you.
the small gas particles, they join together and they become a liquid. Is there anyone else that wants to ask me a question? Okay, so what I'm going, hi. Hello.
Hello, ma'am.
Hi, I can't hear you.
Ma'am,
Yes,
ma'am, should we still do that homework or should
about
we leave
the
it now?
degree Celsius. Okay, so what I want
Yes,
you to
ma'am.
do for homework is, we already got the answer. For home, I want you to write a summary. I want you to write a summary of everything that you've heard so far. The processes of evaporation, condensation, about how if you add energy to a solid, liquid, or gas, what happens if, and then heating and cooling, and the processes of heating and cooling, and how the particles move. So would you be able to do that as homework tomorrow? I actually don't want to continue with density because I can see that you need a more solid foundation of grasping the changes of state. Is that a good idea? Maybe you can go down, write it down, and then if there's any questions of whatever you don't understand, then you can come back tomorrow and ask me before I go to density. Is that okay? Any questions? Yes. Can I ask my host to unmute you?
Oh,
Hi.
yes. Hi, ma'am.
Hi.
Ma'am, can you tell me the example of the cake on density, ma'am? I didn't really understand it.
Okay. So I'm good. While I find the slide, I'm just going to explain. So now you see, when if I look, you look here. Now, when we have the cake, now you would say that it's very dense cake, like a chocolate mud cake. Now, in a chocolate mud cake, they put, you have your flour, you have your milk, you have your sugar, you have your butter, but then they also put like cream in it. Now, cream is is a thick substance, and it makes your cake more dense. Do you understand what I mean by that? But what I want to do is, in tomorrow's lesson, as I go through the slides, you'd be able to understand it much better. I don't want to go through this section because we have 45 minutes and it's basically only 1 minute left for our tutorial to end. Okay. Um,
Thank you,
does
ma'am.
anybody want to recap my lesson? Can you tell me what I said so far in changes of states in your own words? You can raise your hand. Hi, I'm only doing recapping of changes of state. I'll ask my host to unmute just one person. Hi. Hello.
Hello.
Hi.
Basically, on the summary of on changes of state is that when you add energy, the particles of a specific substance become more loose and they start to melt and evaporate. And then when you take away energy, the particles become closer to each other and eventually lock onto each other, which is when you condense liquid and then you solidify it.
Well, that's very good. Well done. I'm very, very proud of you for that. So let's do a quick summary of, not this one. We do a quick summary of, okay, we're not going to do a quick summary. One other person, you can raise your hand. Hi. Hello.
It's me.
Yes.
It's about density and all that.
Okay, so density we're going to do tomorrow. We just did changes of state today because I needed to go slowly because some people needed to grasp the concept. Remember that we all learn at different paces, which is okay. There's absolutely nothing wrong with that. And if you actually go slowly, you actually tend to grasp the concept better, and and you can process the information at home, and it actually helps you with your learning.
But it's
Hi.
also about state of matter also.
Matter?
So isn't it like when you are you're gaining heat, you're putting heat to a solid and a liquid, like it also breaks the forces of the solid and the liquid.
Okay, what breaks the forces?
Like when you're adding heat energy to
That's
the
very good.
solid.
Okay, that's very good. One last person before we log off. Okay, so you can contact me on ahafea@gmail.com, and you can follow us at Africa Teen Geeks #down lockdown eSchool. If you would like any information, you're welcome to email me and I will provide a greater explanation to you. I enjoyed my lesson and I hope to see you tomorrow for density. Goodbye, everybody. Have a lovely day. And don't forget to write your summaries of today's lesson. I will test you on the information that we discussed today. Thank you. Bye bye.